Okay, today we're looking at a couple of things, and these notes that are on this presentation, you'll find them on the compass thing for today's lesson. So we're looking at things called power functions, and all power functions are simply, as it says there, something which is y equals x to the n. So it's x to some power. Now, in this case, we're looking at n being positive and also an integer. So positive whole numbers. So as we know, there's a whole bunch of positive whole numbers, 1, 2, 3, and so on. Some of them are odd, and some of them are even. And so when we power functions, odd power functions and even power functions, that's what we're referring to. So if n's odd, these are odd power functions, and all odd power functions have the same sort of features. And so we haven't got any translations here, we're just looking at the basic one. So examples I've got here in this diagram here of fx equals x cubed and fx equals x to the 5. So when you look at these, you'll notice that they all go through these 3 points. So they all go through 1, 1, 0, 0, and -1, -1. And it's just how much curvy stuff it is. And from x cubed, the black line, and then x to the 5, you can see that it's flatter in the middle and then curves around and curves up. So, as it says down here, these are the common features. So they pass through those points I've mentioned, stationary point of inflection at 0, 0, n gets bigger, flatter around the point of inflection, so in the middle here, flatter in there, and steeper in this bit here or here. Alright, so they are odd power functions. So once we know that odd functions have that kind of shape, we can then sketch them. Alright, so here's an example of something we're going to sketch here. Yeah, I apologise for that, but the iPad only has limiting editing abilities, so that's what you're stuck with. Sketch the graph of y equals negative x minus 1 to the power of 3 plus 2. So, first of all, what are our transformations? So, we've got the minus there, so that's reflection. In x-axis. We've got this minus 1 here, which is a translation. Right one. And then we've got this plus 2, which is a translation up 2. Alright, now, so if we've combined these two things here, translation right 1 and up 2, that's going to do for our point of inflection. So our point of inflection, instead of being at 0, 0, is going to be moved to the right 1 and up 2. And so there's our point of inflection. Alright, so what that then means, and I'm going to shoot to the next page here, because I need to draw a bit of a graphy thing. Alright, here's a bit of a graphy thing. So we had our point of inflection. Our point of inflection was at 1, 2. So we've got a point of inflection there. Now, we know also that there's a reflection in the x-axis. Alright, which is good and it's nice and it's handy to have, but this, when it wiggles, is going to cut through the x and the y axis. So if that's the case, then we should actually find out what they are. So for our y-intercept, x would be equal to 0. So that means that y equals negative 0 minus 3, minus 1 to the power of 3 plus 2. And when you figure that out, you get 3. So it goes through there. Alright, and then also for the x-intercept, we know that y equals 0. And so 0 equals negative 0, not 0, x minus 1 cubed plus 2. And when you do some rearranging, and this is in the notes that are on the compass page for this lesson, you get that x equals 1 plus the cubed root of 2. And then you can work out what 1 plus the cubed root of, and when you do that, it's about 2.25. Now, we wouldn't give that, we'd give the exact form, but what that does do is it tells us that it's about there somewhere. So then we draw our graph, and so the reflection, as we know, so instead of going around here like this, get rid of all of those, it's going to go down here like this, something like that. Alright, so there's that example. Alright, next, got another example that's in those notes there. Just read through that and have a look and see if you can follow that. It's a little bit confusing. Alright, so I better walk you through it. So find the image of the graph y equals x to the 5 under the following. So let's have a look. So this is what happens, x and y. Start with them, and then we reflect in the y-axis. So if we reflect in the y-axis, the x changes to negative. Then after that, dilation of factor 2 from the y-axis. From the y-axis, that's the x that changes. Factor 2 from the y-axis. Then it says translation 2 units in the x direction, minus 2x plus 2, and I'll do these at the same time, and then 3 in the y direction. So that's what we get. So this is x dashed, and that is y dashed. Alright, so if we go on the next page, that means that x dashed is equal to minus 2x plus 2. Add 2, divide by negative 2. You find that x dashed minus 2 over negative 2 is x. And y dashed is simply y plus 3. And take 3, y dashed minus 3 equals y. Because what we're going to do is we're going to replace the x and the y, the old one, by an expression with the image in it. So this goes in here, and this goes in here. So when we do that, you end up with y dashed minus 3 equals x dash minus 2 over negative 2 to the 5. Then there's a whole bunch of stuff that you do, and so then, and they're all in the notes step by step. You get an image which is y equals negative 1 over 32 x minus 2 to the 5 plus 3. Alright, so the steps in here are in the notes that are on the page. Alright, so that's odd one, that's an odd one, that's nice. Alright, so these are even ones. We know even parabolas, we know that. It's a similar kind of thing. Our turning points there, they go through 1, 1, they go through negative 1, 1, and the bigger the power, so like the red one's the x to the 4, it's got that same flattest round the turning point and then steeper thing, the same as odd ones. The only difference is odd ones wiggle like that, even ones wiggle like this. Alright, so example of an even one. Alright, this is something we're familiar with. Parabola, graph of y equals a x minus h. Oh, it's not a parabola, it's a power of 4 here. Quartic plus k, but it's the same. It's that same turning point form as a parabola. So turning point at 2, 2. So there's our first key thing. Turning point at 2, 2. So there are our translations. So as we will already be aware, there's our h and there's our k. So if we stick them in, what we know then is that y equals a x minus 2 to the 4 plus 2. So then we've got this a here that we need to find, and we've been given a point. So if we put that information in, 4 equals a 0 minus 2 to the 4 plus 2, and if you do the calculations with that, take 2, do negative 2 to the power of 4, etc. You find that in the end, and this is in the notes, that a equals 1/8. So our final is y equals 1/8 x minus 2 to the 4 plus 2. Alright, so that's the first part of today's lesson. The second part is finding rules with some other information. Alright, so there we go, that's all looks very nice, nice white splodge there. As I said, the iPad has limited capabilities of editing, so you get a splodge. Alright, so we've got to determine rules, and there's a few different things we can do here. So what do we got? We've got the graph shown here. We've got a couple of asymptotes shown there. We've got a y-intercept, and then we've got the shape of the graph. So we've got a bit here and a bit here, and a bit here and a bit here is a truncus. So a truncus, a form of a truncus. Remember, truncus is the y equals 1 on x squared. But in this case, we need to put some transformations in there. So the transformations that we would have, then that would be y equals a over x minus h squared plus k. Alright, we've already got a couple of bits of information that we know. So we've got this asymptote here at x equals 2 being an asymptote. X equals 2, and what that means is that then h is equal to 2. Got another asymptote, a horizontal one right here, and that's at y equals 1, which then means that k is equal to 1. So straight away, we're going to go to the next page then. We have y equals a over x minus 2 squared plus 1. Then when we come back here, we notice that we have an intercept there. So that intercept is the y-intercept, so it has coordinates 0 and 2. So we can now use that, 0 and 2, in here, 2 equals a 0 minus 2 squared plus 1. And when you rearrange all of that, you end up with, and this is in the notes on the thing, but you end up with a equals 4. So what that then means is that y equals 4 over x minus 2 squared plus 1. Alright, one more example. So you may be given some other information, such as this one. Alright, so in this one here we're given a couple of points, 2, 1, 10, 6, and we're given an equation. We're told that this is the equation. And we're asked to find the rest of the equation. So, if I put 2, 1 in to that, I get that 1 equals a square root 2 minus 1 plus b. And when I neaten that up, I'll find that this bit here is equal to 1 and the square root of 1 is 1. So I got 1 equals a plus b. If I take the other point, and the other point is 10, 6, and put that in, then I get that 6 equals a square root 10 minus 1 plus b. 10 minus 1, of course, is 9. The square root of 9 is 3, so I get 6 equals 3a plus b. These two things would be simultaneous equations, 1 and 2, and then we would solve them simultaneously. And when you solve them simultaneously, either by hand or using your calculator, you get that a is 5 over 2 and b is negative 3 over 2. So then when we stick that in, our final equation then is y equals 5 over 2 square root x minus 1 minus 3 over 2. Alright, so on your work plan, that's exercises 3G and exercise 3